Welcome you all at the lecture series of operating system. In the last video, we have seen what is the process synchronization, why we need that, and what are all the main requirements we need to find out the solution of process synchronization. The example is the producer and consumer problem we have seen, and what is a producer means the producer produce an item and the consumer consume the item. Here we are using the common shared region is that buffer. So based on that, these producer and consumer are executed concurrently. We come out of the race condition because the two processes are share the common region, and also the execution of the two processes is concurrent means the order of execution depends on the output of the results depends on the order of execution. So that leads to the race condition, that is a critical section that leads. So the critical section problem means for every critical code we have a set of entry and exit sections. The critical section means it is a segment of code. So the any process is want to enter into the critical section. Before that, it go do the entry section, and after the entry section execution. Entry section is sanctioned, that process is entered into the critical section. So after that, the exit section, that process give the signal to other processes, it is come out and we can use the critical section. So this is the common structure of any process in the critical region. So in the last video we have seen what is the solution to the when you are find the solution to the critical section problem, that could be satisfied with the three requirements. First one is a mutual exclusion. So what is a mutual exclusion means, if you have a process P1 and P2, suppose if process P1 is executing in its critical section, then no other processes can be executing in the critical section. So this is a mutual exclusion requirement, that is a primary requirement. And next is a progress. So what is a progress means, suppose if no processes is executing in the critical section and there exists some processor or wish to execute the critical section, so the order of selection of the process that will enter the critical section next cannot be postponed indefinitely. That means we have to select the next process immediately to enter in the critical section. We cannot postpone indefinitely. So the next execution should satisfy the condition of that process could not execute the remainder section. So that process can execute in the critical section. Next is a boundary waiting. So the bound must exit on the number of times the other processes are allowed to enter the critical section after a process has made a request to enter its critical section and before that request is granted. So the suppose you have a two processes P1 and P2 is want to enter into the critical section, but P1 is again and again executing the critical section means we cannot we cannot exceed the limit of that wait for P2. So we can allow the P2 in the some time, so that bounded limit of the waiting of process P2 should not be exceed. So that is the bounded waiting. So these are all the three requirements could be considered whenever you produce the solution to the critical section problem. So the critical section solution means that is a two types of solutions. One is a hardware based solution, other one is a software based solution. So the software based solution is that Peterson solution. So the Peterson solution is mainly satisfy the primary condition of mutual exclusion. Peterson solution have the variable is turn and boolean variable of flag. So turn means what is the next process is want to enter the critical section, and the flag, that is a boolean value that could be either a true or false. If the flag value is true, means that process is ready to execute in the critical section. So suppose one process, you have a two process P1 and P2, means the process P1 is entered into the critical section, that two variable as turn is equal to I, and also the flag value of process PI should be true. So these two statements should true, means that process is entered into the critical section. For example, here is a one solution of Peterson solution using only one variable as turn. So while turn is equal to j, that means that condition is false, means we can do the critical section. So what it mean with turn is equal to j false, means turn is equal to I. So the I process is entered in the critical section. So once the process entering into the critical section, that process give the turn to the next awaiting process and enter into the critical section. That's why the turn value is equal to j. So if it is equal to j, means after that the turn is equal to j. After completing the critical section, the turn is equal to j, means the process given the turn to j and come out from the critical section and go to the remainder section. Next, algorithm 2, the Peterson solution, we are using the two variables like turn and boolean variable as flag. Assume that the load and store machine language instructions are atomic. Atomic means once you enter into the condition, that statement fully should be executed. Suppose you want to enter into the function, means that function is fully executed. After that, there is no interruptible in that particular coding. So the variable turn indicates whose turn is it to enter the critical section. Next, the flag of array is used to indicate if a process is ready to enter the critical section, the flag of I is equal to true, implies that the process Pi is ready. So this is the Peterson solution using the two variables. First is the flag of I is equal to true. Next, the turn is equal to j. So it provide the turn is equal to j before entering into the critical section. So what is the entry section code is, while flag of j and turn is equal to j, means that condition is true, means jth Pj is ready to enter. Suppose the condition is false, means now the Pi is used the critical section, and after the critical section the flag of I is equal to false. So the process Pi indicate the process Pj that is come out from that critical section. So you can use the critical section. So finally, after we are having the remainder section, and process Pi is come out and Pj is entered into the critical section. So this is a Peterson solutions. That is a software based solution for the critical section problem. I hope that you will understand what is that main three requirements we need to provide any solution to the critical section problem. And we have the two types of solution. One is a Peterson, that is a software based solution, and a hardware based solution. So the Peterson solution, we are using the two variable as turn and flag variable, flag boolean variable. You based on that variable value, that which process is used the critical section is fixed. I hope you will understand what is the Peterson solution. So that solution can be applied to that example for any software based solution of process synchronization. Thank you.